I am welcoming you all to learn the new concepts today. Yes, in today's lecture, we are going to discuss new concepts, that is progression. Yes, arithmetic progression and geometric progression in this lecture. Are you all ready for learning the new concept? Yes, let's get started. Progression. What is a progression? Progression is nothing but a sequence in which the consequent numbers have some relation. Okay. Say for example, if we take natural numbers 1, 2, 3, in that we will get the number by adding 1 to the previous number, right? After 1, 1 plus 1, 2. After 2, 2 plus 1, 3. Likewise. Okay. This is a super example for arithmetic progression. In case the sequence has common difference as relation between two consequent numbers, then we call it as arithmetic progression. In case the two consequent number has common ratio as its relation, then we call it as geometric progression. Common ratio in the sense, if we multiply the common ratio with the previous number, then we will get the current number. I mean, previous number into common ratio is nothing but the current number. Okay. On multiplying the common ratio with the current number, we will get the next consequent number. Okay. With this note, let's quickly get into arithmetic progression definition. Okay. The sequence in which the consequent number have a common difference of d. Say for example, a is the first term of the sequence, then we will get the second term by adding d, where d is the common difference. Similarly, we will get the third term by writing down this is the second term and we have to add the common difference d, so that we will get the third term. On simplifying, we will get like this: a plus a comma a plus d comma a plus 2d a comma a plus d comma a plus 2d comma the next term. Very good. A plus 3d, right? Okay. Likewise, the sequence goes on. Here is one example for us. Can you tell me what is the a here? Good. 1, right? Because a is the first term of the sequence here. Then, can you find what is the common difference? Brilliant. 2, right? Why? Because here 3 minus 1 is 2. Similarly, 5 minus 3 is 2. So, the common difference here is 2. Very good. Okay, let's quickly read out some basic formulas based on arithmetic progression. If we are supposed to find the nth term of the sequence, nth term in AP have one formula. Let's quickly read the formula. Tn is equal to a plus n minus 1 into d. A is the first term, n is the term which we are about to find. I mean, if we are about to find the 30th term, then n here is 30. Then what is the common difference, right? Okay. Then how we are going to find the sum of n terms of AP? Say for example, they'll ask what is the sum of 25 terms of the sequence 1, 3, 5, etc. In that case, if we don't have formula, what we have to do? We have to list out the 25 numbers, the next step, then we have to add everything, right? Okay, we don't want to do such complicated steps. We have simple formula in our hand, and this is the formula. Sum Sn is given by n by 2 into 2a plus n minus 1 into d. Okay, here a is the first term, n is the how many terms we want to find. Say for example, we are going to find sum of 25 terms means, then in that case n is given by 25. Okay, let's all read the formula one more time. Nth term in arithmetic progression AP is given by Tn is equal to A plus n minus 1 into D. Similarly, sum of n terms in AP is given by Sn which is equal to n by 2 into 2A plus n minus 1 into D. Kindly note down the important formulas, okay? Let's quickly get into the derivations which we made using the formula of arithmetic progression. Using the sum of n terms in AP, using this formula, we have some derivation, 3 important derivations. Let's read it. 1 plus 2 plus 3 plus etc. is equal to n into n plus 1 whole divided by 2. Similarly, 1 square plus 2 square plus 3 square plus etc. is equal to n into n plus 1 into 2n plus 1 into whole divided by 6. Next, sum of cube of n natural numbers, right? 1 cube plus 2 cube plus 3 cube plus etc. is given by n square into n plus 1 the whole square whole divided by 2. In the question paper, they will even ask not like this 1 cube plus 2 cube plus 3 cube. They will suddenly ask what is the sum of square of 25 natural numbers. In that case, we have to use this formula where n is 25. Okay. They will suddenly ask what is the sum of n natural numbers as a question. So you have to write down n into n plus 1 by 2. Whatever the question is asked, we have to understand it clearly and we have to answer. The main requirement is you have to learn the concept in depth. Okay, you should not just mug up 1 cube plus 2 cube plus 3 cube is equal to n square into n plus 1 square whole divided by 2. It is not important. You have to realize you are reading the sum of cube of n natural numbers. Okay, here are the 3 derivations. If you want, please pause the video and note it down. Okay, let's read it one more time and get into the geometric progression. Are you all ready to read with me? Good. Let's read it together. Sum of n natural numbers 1 plus 2 plus 3 plus etc. is equal to n into n plus 1 whole divided by 2. Second, sum of square of n natural numbers, that is 1 square plus 2 square plus 3 square plus etc. is given by n into n plus 1 into 2n plus 1 whole divided by 6. Similarly, third derivation, sum of cube of n natural numbers, that is 1 cube plus 2 cube plus 3 cube plus etc. which is equal to n square into n plus 1 the whole square whole divided by 2. Hey, congratulations! We have completed the first part of our lecture, arithmetic progression. Let's quickly get into definition of geometric progression. Are you all ready to read the definition? Good. Let's read it quickly. The sequence in which the consequent numbers have a common ratio of r. Here, let's consider A as the first term. By multiplying the common ratio r, we are getting the second term. AR is the second term. On multiplying with the common ratio r, we are getting the third term as AR square. Okay. On simplifying, we will get the sequence like this. A comma AR comma AR square comma AR cube. Good, you all guessed it right? Good. Here is our geometric progression example, example sequence. In this sequence, can you tell me what is the A term? Super. 2, right? Okay. Let me check your intelligence. What is the common ratio in our example? Wow, we all find it, right? 2. Here it is simple sequence so that you have found. In the bigger case, it will be difficult. Let me tell you one shortcut. What you have to do, you have to divide the second term by first term. 4 by 2, 2. Okay. Similarly, you can take any two consequent terms. What is the matter? You have to divide the previous number by, you have to divide the current number by previous number. Otherwise, next term by previous term. Okay, 8 by 4 or 4 by 2. On dividing, we will get the common ratio as 2, right? Okay. In difficult sequence also, you use this method. Next, let's quickly read the formula of geometric progression together. Okay, are you all ready for learning? What we have learned in arithmetic progression? Two formulas. Nth term of AP and sum of n terms, right? Okay, here also we are going to see the same thing but different formula. Okay, first formula, nth term in GP. Nth term in GP is given by Tn is equal to A into R to the power n minus 1. Here A is the first term, R is the common ratio, n is the nth term. I mean, if we are about to find the 100th term of the GP, yes, 100th term, we can find it easily using our formula, right? Okay, if we are about to find the 100th term of the sequence, here n is given by 100. Okay, let's quickly read out the second one, sum of n terms in GP. Sum of n terms in GP is given by Sn is equal to A into 1 minus R to the power n whole divided by 1 minus R. Here it is written R into n. I'm sorry, it is R to the power n. Okay? You understand it, right? Let me clearly write it down in one new page. A into 1 minus R to the power n whole divided by 1 minus R. Okay? This is the sum formula for GP. Let's quickly read the formulas one more time. Nth term in GP is given by Tn is equal to A into R to the power n minus 1. Similarly, sum of n terms in GP is given by Sn is equal to A into 1 minus R to the power n whole divided by n minus R. Okay, that's all for the today's class. In the next class, we are going to see HCF and LCM concepts. So let's see in the next class. Hope you all enjoyed this class, and if you have any suggestions to improve my teaching method, please comment below and subscribe my channel if you find the videos are useful, and please
Share to the people in need of it. Thank you.